Who are new in the path 2? 2 or 3 folks. I understand. So we cover some of the basic design architecture, best practices, routing, etc. So some of the conversation will be a little bit awkward for you guys, but recording is available. They are not videotaping me, so if you want to see me, go see US presentation, because that has the video and audio. The slides will be available within 1 or 2 weeks. By the way, I have tons of other hidden slide that is important as well, but lack of time, I cannot present all the slides, right? So I unhide all the slides so you will get the full version of it, right? This is a critical piece that I want to share, and so you can get both sides, right? So the piece that we were talking in this session was the data center sizing and topology. That's the first topic. Then we will cover the security service design. First 2 part is basically a entire session. Then there is a NSX with SDDC use case, just to kind of give you an idea how all things comes together as a part of the end-to-end architecture, right? So the previous sessions we were trying to define this piece, right? What are my choices in design, right? What should I always design, compute, edge, and management separately? What are the requirements for separations, like you have a compliance requirement, multi-tenancy requirement, how many VDSs, etc. So that's this idea of this first few slides is to give you a ability to learn how to throttle the design and choices in terms of component, placement, availability, bandwidth, etc. Right? So if you start with the idea of the design, and I was going through that previous slide, all the questions that I asked, where should I put that control VM, where should I use the edge services gateway, what are the requirements? So key point here that people often misconstrued is that NSX doesn't put any requirement on, like, okay, how big or how large. It's flexible. You can run it on a single host, but then I question what is you trying to achieve. You can run it in a 3 host with the simple to experiment, right? Or sometimes people run only 2 hosts in a remote branch office. That's an interesting use case, right? But in that case, you're not using the full-blown NSX stack, right? So key is that understand the use cases. Either you can grow from a full-blown design, full-stack design, or you start with the micro-segmentation and move on. The key point here is that understand the edge resources. Edge VM, which is the north-south gateway, is a highly CPU-centric function because you're forwarding packet, right? So it's a very finite requirement. It imposes called resource reservation by automatically in your cluster wherever you deploy that edge, right? So it has a very specific vCPU requirement. So important thing is that resource reservation will not allow you to share that vCPU, etc. The other piece is that a licensing requirement. We generalize it. VDS is now comes with as default. Log insight comes with by default with NSX. There is an standard advanced and enterprise license. I don't sell any of these licenses because I don't get any money out of it, right, except salary. So it depends upon your use case and feature sets that you want to sell or use. So it's important that it's a flexible way of introducing NSX in the design. So if you look at it, you start with a very simple single rack design, or you can say 3-host design. You can say, hey, I need only NSX manager because I only want to do micro-segmentation, because that's what the best use case that I find right away I can get these things going. I don't want to complicate the life because your mobility is within the rack. So why do you have to have a VXLAN? Probably not needed, right? Important point is you also don't need edge services gateway because you have a default route over there coming from the north-south. You have a layer 3 routing there, right? So you can start with that, but then you can grow into a more design, and the design comes with the idea of okay, I can run a centralized edge. What does that mean is no distributed logical router. So I can introduce an edge with the idea that I run active standby edge. Notice the difference. One is active, one is grayed out. I will change these pictures in the few slides so because of the way I put the components. If you also notice that I do not put a active control VM along with this active ECMP because best practice is not to mix them, right? But you don't need any control VM, you don't need a edge VM to start with, right? But if you have an idea that let's say I want a services now because I want load balancer or a NAT or a VPN, then you can deploy this active standby gateway. That becomes your default gateway and you use the services. Now the flexibility of choice comes, should I choose 2 vCPU license or 4 VCU, the edge sizing, right? Depends upon the performance I want and the throughput I desire, right? Finally, you don't also need to complicate routing. There is only 2 ways to go out. Put a static route and point it to HSRP, right? That will work as well. That means you don't have to deploy any of the routing in the edge, northbound, right? If you want to just simple design, right, you have a choice. Then you grow into, let's say, hey, I might need another rack or a 2 rack. Now I'm talking mobility, decoupling from the underlying fabric because you have a layer 2 or layer 3. That's where the control VM and the controller comes in a picture, right? So you can throttle the design starting with a single NSX manager, run a microsegmentation in a small cluster. The question also becomes is that whether this small does not mean small businesses. Because you could have a DevOps rack, right? You can have a small satellite data center where you can have a small businesses running that and you just want VPN services for them. Or a NAT because you don't have expensive hardware to buy, or edge firewall because you don't want to do the dedicated firewall that's such a small rack. So you can run different services as part of it and you don't need to complicate with the distributed logical routing because mobility is within the rack, life is good, right? Because you're not changing the default gateway, right? You're not going from one rack to another. The question will come from that, and there's a dedicated session that Shahzad does for us that goes into all the details of the licensing, some of the caveats on when you configure the microsegmentations and how do you exclude certain vCenter and management because you're going to block yourself out if you use the same edge devices and firewall on the same cluster, right? Because we use the DFW per NIC for the whole, all the resources in the cluster, right? So if you go from there to a choice that, hey, I want somewhat medium scale design, and this number called small, medium, large, normally I attach with the type of virtual vCenter design you have, a small, teeny, small, medium, large, right? That's what my characterization is, right? You choose another characterization, but the point here is that the natural question comes that when I want to grow, when I want to have a little larger scale design, what choices I have? Should I mix and match edge cluster or edge resources with the compute? Should I mix and match edge resources with management, or vice versa? There is a combination of it, right? The factor that I suggest is that combine edge resources with management. All right, there are certain designs from VMware coming out that says combine edge resources with compute. Well, that's a fully prescribed, supported design as well, but that is not what I recommend normally. Why? Because you're going to grow compute. The whole idea of doing this design, medium design, with the hope that you're going to grow. What do you grow most? Not edge resources, not management resources. You grow compute. Also, when you grow compute, you don't have a same type of hardware. In other words, when you can have a 24-core CPU or 48-core CPU, you can have a different type of workload, right? So the idea is that the compute resources are malleable, flexible, and disparate. And you want to introduce edge there where edge requires a specific resource reservation. And there is a operational boundary, right? The VM admin or the computation workload guy wants to have that resources available to them because they arrange the DRS and anti-affinity and the clustering and the separation. You don't want to mix up your edge resources requiring a vCPU and you have a highly oversubscribed or highly CPU intensive application as well. So this is a classic separation of a understanding how your workload behaves and what your edge resources are required, right? So in a medium design, what I do typically, because it assumes I need a higher bandwidth, that's where the topology changes and the configuration suggestion changes, that I put 2 ECMP node because you have a 2 uplink, life is good, 1 on each host. So if one host fails, other host is available. DRS can occur on the other host, but the point being is that you don't lose both hosts at the same, both edge ECMP same time. If you notice that control VM is on the different host, so you don't have a double failure. Your standby is on other host, so if this control VM fails, this standby will go active. Now you have a ECMP edge and a control VM both on the same host. Now, you know that if that host fails, you will have a problem. So you have to actually schedule, or once you recover the third host, you can schedule to the flip over from one host to another, right? So you need that manual intervention in case, or you can automate it, depends upon how sophisticated your design you want to be, right? Other key important aspect that in this case, I assume that you need a bandwidth, so I use with the ECMP design. The important piece is that you can start here and grow to the large design, or you can start with a small, convert it into a medium design where you separate the compute cluster and edge cluster. When you do that, you have to do re-IP, right? So what's harder to re-IP? vCenter is harder to re-IP. It's harder to re-IP NSX manager, right? Edge, you can redeploy it and life is good, right? Your compute VM workload is harder to re-IP, right? So that's why important to consider that if you are growing, use edge and management together in order to grow out of it or grow into it, right? Rather than combining with compute, right? Later on, we will learn about how do you scale beyond it, right? So if you look at the design point I'm making here, I'm making a cost decision. In a small design or medium design, you don't need a super high availability. So I'm using only 3 hosts, each with the unique controllers in each host, each with the dual redundancy of ECMP, etc., right? That's a minimum recommended design if you want to be resilient and be aware of the failure that we talked in the previous session, right? We will talk next. If you look at it, this design, I give a little bit more information on it, that in this design, you can also start with in a small or medium design. You can start with the large 2 vCPU and then grow and upgrade it to the quad large. Depends upon design considerations. A lot of people don't know this, that this edge is a multiple use resources. That means I can run ECMP here, but to do load balancers and VPN, you can deploy another instance, right, near the application, right? So that's where you can use combination of both edge services, in this case the load balancer, and the ECMP for your throughput and bandwidth, right? That's another flexibility required, right? Important point here is that lay out the conversation with you about how you want to grow or where you want to starting point, right? And then grow into it. So if you go from this design to now consider the original slide that I had, is that what is the large design characteristic, right? Variable workload, it's on demand. You want a compliance requirement, that means you have a HIPAA or the regulation requirement, or a security designs, or a PCI compliance that we normally use it in US. There is a similar European requirement, or a continent where you come from, right? So there is a dedicated management cluster is desired if you have a SRM. If you plan to use a multi-VC data center, or if you have a multiple VCs, that means you have a dedicated edge cluster, right? At that point, if you notice it, and this is on the first few slides, we talked about it, right? That typically controller goes into the same cluster as the NSX manager, right? Here, I do that, but you have a choice of putting this controller cluster over here on the edge resources. Why? It's an optimization of edge cluster, right? Because notice that in this design, I'm starting with 4 hosts. In the previous design, I started with the 3 hosts because the bandwidth requirement is not as high. Here, I know typical design starts with what? A 410 gig uplink that comes out of it. That's why I have a 4 edges running, 1, 2, 3, 4. So now I'm combining 2 edges per host, total 40 gig as my baseline design. You don't have to do that, but it's to give you an idea how do you scale. And also, I'm putting a active and control VM on 2 different hosts. Why? Because now I have a full resiliency. If the control VM host fails, I already have an independent standby active VM in a completely different host, right? Also, if you move this controller to this edge cluster, it allows you to optimize your core design, the CPU core design, right? Because that edge cluster can host controllers, edge VM, service VM, log inside VM, monitoring VRNI resources, etc. So edge cluster could be a multifunctional role along with your edge forwarding and edge services, right? Question? Yeah, sorry. Pardon?
You're moving all this stuff to the edge cluster, transforms it into the management cluster.
His question is that if you slowly move all these components from management to edge cluster, it becomes a it kind of behave like a management cluster. You can point out, yes, somewhat that statement is true, not because I did not say move your vCenter, move your NSX manager. That remains in a management cluster. Why? Because that management also cluster holds your SRM VM or a management VC to control the SRM behavior, right? Or think about it, another NSX manager and another VC can go into that NSX manager, and you have a complete set of another edge cluster for that domain. Now we are talking 2 different NSX domain, right? Let's say you merge a company, then you can put that resources in the NSX management domain, right? So yes, some of the log inside or VRNI, I'm trying to optimize a design and a host utilization, mapping the bandwidth requirement and the core. Typically you can buy an 8-core machine. It's not cost effective. So then you waste CPU resources over there. That's why I'm trying to balance that argument with what is right thing to do when you want to grow, right? You see what I'm saying? So that is important. If you look at the edge vCPU guideline, it's a right on the money conversation, right? That a 2.6 gigahertz is what we test with, minimum, right? Higher the CPU go, better you are, okay, in terms of the throughput. So always prefer the higher CPU sizes, but 2.6 gigahertz is the baseline. Higher core can be used based on the virtual machine that may need a 4 by 10 gigabit design, which is Mr. 4 uplink guy. Right? So that is an important, right? Keep the CPU socket consistent, because if you move edge resources, you want to make sure that you get the consistent performance, right? So the 4 hosts, not mandatory, but it's good to have a consistent socket core requirement, right? So if you go from this argument, your natural question is that in a large scale design or any normal design, if I want a throughput or a performance or rack availability consideration that my friend was talking about, let's talk about that performance on a few slides fast. So question for you, should I do 40 gig design, 10 gig design? We'll work with the both, right? But in the 40 gig design, you have to have considered this, the PCI limitation exists, right? The 2-lane versus 8-lane design, right? So personally, I prefer single 40 gig port per VNIC, all right? Because the PCI bandwidth limitation will come in the picture. So your throughput is limited on the NIC card itself. So 2 40 gig Unique VNIC is a ideal design. More importantly is the bottom line. If you want to get line rate, of course, you need there is a performance session that is not covered here in the European session. We tried, but session slot was limited. Samuel Komu does this performance session in US, so go look at that. That it requires that you enable these things and enable card, TSO, LRO, and RSS enable card, disable CPU power saving mode, and disable the hyperthreading on a host. Question?
If I have a high performance mix, like to do VXLAN offload.
That is exactly what this is, VXLAN offload. That is what I mean. This is for the VXLAN offload. You will not get a line rate if you do not use a proper VXLAN offload. And go through the HCL hardware compatibility guideline we prefer, right? And that points to my next questions or the next slide. In a couple of minutes, we'll talk about it where it's restricted. So there is a performance session. You can look at it. It's NET1536BE. What is that number? 1343BU. That is it's done in US. You can listen to that performance considerations in detail. This is a classical throughput that I describe and I tell you. Remember we talked about it that, hey, keep your MTU to 9K in a network fabric. Here is the performance difference between a 1500 byte MTU and a 9K MTU. Now next things you're going to ask me, hey, I cannot do 9K on my VM. Yes, you can, but it's not a normal best practices. I know it's a default is 1500. And you're going to tell me I'm not going to get a good performance on a web application because it has to go out, right? That means most of the time my MTU will be 1500 because it goes over the campus or goes over the WAN or internet, right? So for a web application, you are a little bit restricted, but we'll work about how to get rid of that design conversation as well. But east-west traffic, so from your app to database, VM, can configure with 8900 MTU, and because you may have a storage backup requirement, right? If you back up so you can have a dual VNIC in a VM, one VNIC with the 8900 MTU, so you can do the backup, or you can run a east-west traffic, which is the east-west application, which is the app to DB and DB to DB, etc. That you can run with the 8900 MTU. Because that normally doesn't require access from outside world, and you can have a better throughput and availability considerations, right? The question becomes is how many hosts, how many rack, how many edge virtual machines or ESG or ECMP gateway I should hope per host. So if you look at this design, I'm repeating some certain concept so that you get into the rhythm of understanding is that a 4-host, this is a typical, now best practices recommendation is the 4-host in a large scale design for availability consideration and a throughput consideration. So if you look at it, there is a 2 ECMP per host, and that host has a dual uplink. So theoretically, you can get both uplink utilized properly and get a better performance with the 2 HVM line rate. Now, naturally, the question of, okay, I want to optimize design. Why? If you notice it, there are 2 different designs, no oversubscriptions and 1-to-2 oversubscription design. So in that case, I'm putting 4 ECMP hosts in a single, 4 ECMP VM in a single host. Notice the uplink is normally 2 by 10. So I have a 40 gig theoretical throughput, considering 10 gig NIC. But I'm offering a 40 gig. Now, things about this, people die over this conversation. Normally, network is always oversubscribed. You don't have a choice because it's a classically, economically impossible to run a spine with a 200 host or 200 spine switches. In other words, your uplink spine bandwidth is typically limited by 20 gig or maximum 40 gig. And if you are a high end, like a trading floor guy, will put 4 40 gig and 160 gig. But then you have a other 40 gig host as well. So typically that's 2 by 3. In some case, 1 to 4 oversubscriptions in the network. By the way, this is TCP/IP. Congestion always exists. It just moves other places. So the important thing people talk about saying, hey, my edge doesn't do line rate, or hey, I have a bandwidth issues. I have yet to lose a customer just because I don't have a sufficient bandwidth, right? It depends upon what type of a design you choose. And this is a quite an okay design. The disadvantage, or rather weakness of this design, is that if one host fail, I lose 4 ECMP edge. That means around 40 gig worth of traffic is down, right? In the other design, only 20 gig traffic goes down, right? But it increases the number of host requirement, right? So it's a design choices that you have to make, right? I have another couple of slides, a UCS slides, right? VXLAN with UCS. It's a reference slide. It's only the 1340 and 1380 VXLAN offload is supported. We are not recommending this VXLAN offload in a UCS. Next thing you're going to ask, that means you don't get a good performance. True. We are talking UCS blade design, right? Not on a UCS rack design, because it uses Intel card. You can run the offload, life is good. So what do we recommend? What do we recommend is a thing called NetQ, which is actually used for a VLAN based traffic. You can also use that for a VXLAN traffic, because VXLAN traffic is offered as a VLAN. And there are recommended configuration, and you will get a much better throughput. Now, you can mix and match your UCS blade. You can have a 1240, 1280, 1340, 1380 with a consistent configuration, and you also get a better throughput for your VLAN traffic. What are those VLAN traffic? Storage, other VLANs that you have, etc. Right? So VMQNet is recommended from our side, right? Now Cisco, my brother-in may tell you differently, but they are very well aware of the previous slide. So normally you should not find any contradictions. Once they fix this piece and you have a general fleet of 1340 and 1380, you can get rid of it, because VMQ, NetQ, they call it VMQ, and a VXLAN offload are mutually exclusive. Right? So keep in mind, this is a very specific requirement that we know of to avoid any headache, right? The last slide is about just giving you an overview of different type of choices you have to make in an edge design, right? Bandwidth, availability, extensibility, requirement of services that you are running. It's a reference slide so that it gives you a good picture of what are the possibilities that you can configure your edge, depends upon a requirement, right? So now if you put all this knowledge which you have about the edge VM, services VM, ECMP VM, CPU, cluster, let's talk about the topology design, right? So this is called a standard enterprise routing topology. Here I'm running this edge services VM in a ECMP mode. That is the question that gentleman asked. You disable all the firewall policies, etc., and you will end up running this in a ECMP mode, active standby design. Why? Because let's say you don't need more than a 10-20 gig throughput. Life is good. You don't need to reinvent the wheel. You can run this design with a active standby. Later on, you can enable a firewall here, load balancer here, or a VPN here. You still have ECMP because we are having a dual uplink. Okay? So the important thing is, here is again rehashing our conversation. This is an active standby design. That means my protocol timer needs to be 40-120 in order to reach that conditions. Now there is one must design aspect people overlook, and it's not properly documented, which is a must keep a logical switch. When you define a logical switch, that means you define a subnet. That's a logical interface on a distributed logical router over here. That subnet mask cannot be larger than /22. We don't recommend more than a 500 virtual machine on a single logical switch. You can have a multiple logical switch, right? You can have a multiple DLR, so it's not restrictive in that sense. There was in older code also one more limitation called we did not allow automatically you to configure more than a 5,000 VM per distributed logical router. And some customer ran into that. We have removed that requirement. You can go higher now, right? So, but this is a must, /22, right? It's a good old based networking practices to not go beyond 500 because it's a single broadcast domain, right? Question.
Limitations to /22, is that because of your broadcast domain or is that because of map limitations on the logical scale?
So his question is whether what's the limitation? We hard-coded it. We hard-coded it to, originally when this product got invented, we had a thought that, hey, let's not kill ourselves with the crazy 1,000 host, 1,000 VM in a single subnet. We are not planning to remove it because it's okay, you can run a multiple logical subnet unless you put a bullet to my head in terms of money. Is it too hard? If you try, bad things will happen because it will override the MAC entries, right? Yeah, it's right now we tied it, actually no, I didn't want to go into that, but since you're insisting, it has to do also to do with the managing the VTAP table. More the MAC address, you have to do multiple VTAP to MAC table entry. That means it's a memory constraints on the how many VTAPs we are running, how many logical switch we are running, that mapping table conversation, right? So right now we restricted ourselves, but it's not a super restrictive requirement, right? You can live with it, trust me. Some are not, but let's not go there, why they cannot. So if you transform this design to, let's talk about ECMP design. So you knew this design. Notice that I have eliminated a standby edge. So I convert that design into a ECMP design. So you start with single edge or a 2 edge, 220 gig requirement, 2 host, but you can scale up to 8 as I was talking about, right, before. The requirement is the same. I'm talking about in terms of maximum with the right MTU size, you can go up to 240 gig. The next question is that what if I need a more scaling beyond 8 ECMP edge? You can do that too, right? How do you do that? So ECMP design, of course, scale it with the incremental bandwidth gain. So you don't have to deploy all 8. You can incrementally deploy 2, 3, 4, 5, 6, 7, 8. But then once you go beyond 40 gig, 240 gig, you can run a multiple DLR. So you have a distributed logical router and set of 8 ECMP edge, another distributed logical router, another set of ECMP edge, right? We support quite a high number of distributed logical router in order to gain the bandwidth out of the system. So it's scaled horizontally as well as vertically in a orthogonal way, right? So if you look at it, that's this design of ECMP with the scale. How do you put that sometime in a practice? So this is a kind of a topology design that the other gentleman was asking, can I mix and match? In this design, what I'm mixing and matching, you have a distributed logical router and 8 ECMP edges. That was the previous slide that we talked. But then on the same VXLAN riot, this is the uplink that comes out of the distributed logical router, you can also attach another instance of edge that runs a inline load balancer with routed mode, or you can run inline load balancer NAT with a private mode. So now you have a production topology that runs over here. You have a DevOps or a QA topology that runs on here, depends upon requirement. Because it's a QA and dev test, you can isolate it, sandbox design, and you do not have a super high requirement of bandwidth. So you are now creating a called 2-tier design. Here, this ECMP and a distributed logical router, and there is a control VM sitting somewhere else, that interact directly with ECMP edge. This edge creates a either dynamic routing connection or a static, depends upon your availability requirement. And you can run now a double-tier routing, right? So two-tier topology is possible, right? What do I gain? I gain a flexibility. I gain a scalability based on a ECMP, right? You gain the services that you can enable on the edge, and also get a security because you are enabling a distributed firewall mesh over here. For the production workload, you have a northbound firewall, physical perimeter firewall. For a QA and a dev test, you can enable firewall over here, and you isolate each other or also protecting from other production traffic, right? So you have a flexibility. Question?
Or you could even add another layer with another DLR.
He's asking, I know, this is a network guy always asks me this question, saying, can you create another layer of, and the answer is possible. Let's not create a stack of stack that fails. Now we have a multiple control point to manage, right? What drives you to that requirement?
Just benefit from the advantages of the DLR, east-to-west traffic between those load balancers.
No, you want to optimize the east-west traffic from here to this guy? Right, but that is going through the ECMP edges.
No, but within the machines on the middle or on the right.
Yeah, so, okay, that's a good point. Thanks for reminding me. He's asking, hey, if I want to have a DLR, see, if you notice it, the difference here is that I'm attaching all my logical leaf on an edge. Here, I'm attaching to distributed logical router. He's saying, can I run a distributed logical router over here? Yes, absolutely. To optimize east-west requirement, right? Further. Agree. If you have a high east-west traffic but low north-south traffic, and yes, you need a services, you can deploy distributed logical router. Correct. I was thinking like 3 tiers of each. That will be too much to overkill, right? So that's a good point. Thank you. Everybody follows what question he asked? Can he run a distributed logical router over here? Answer is yes. Absolutely. Can he run another set of ECMP? Answer is yes, you can. And that's the next set of design choices we try to give you. These two slides are same as the previous one, but little automation viewpoint. If you use the VRA, we use this automated slide. So we pre-create this distributed logical router and ECMP. You can automate all of your leaf creations as well as logical load balancer attached to it on your application segment. That gets automated very easily. You only do is pre-create ECMP and your distributed logical router via your cloud admin. The right side is a kind of a QA DevOps topology in which you get out of the box, you pre-deploy this NSX Edge HA, and you can deploy Edge HA with load balancer configuration and these 3 segments automatically through VRA. That doesn't mean you cannot have another topology automated, but that you have to do it via custom automations. These are 2 called automation-friendly topology. That's why I'm generalizing the design based on that. But you can create one. Like example here. Same topology, same configuration. You have a distributed logical router. This is a production. It maps to called multi-tenancy, VRF, on your northbound router, right? And the QA topology on a separate VRF because they don't want to mix up the routing table or a convergence or any, you can have a duplicate IP addresses or redundant routing table with the multiple routing advertisement, right? So you use the same topology, and against I have a few other topological slides that you will learn from the hidden slide as you download it. But the key point is you can also put this distributed logical router anywhere, right? You can run 5 sets of distributed logical router, each having a ECMP design, or each having a enterprise edge gateway design with the services. So it's that way it's flexible, right? Question? All right. So I'm going to talk a little faster because I want to cover a few things here, important. And this is a security design. The key part is this is a kind of give you an idea that, look, you have a distributed firewall, you have ecosystems, it's any network, any application, any topology. You can use the service composer to create your workflow. You can use security group and a policy, and finally the ecosystem, the Palo Alto, Checkpoint, or a Fortinet, in order to create a comprehensive design, a security design, right? So I do not go security design lifecycle. I don't go into the business of how to configure security, but I'm trying to give you a design how you should think about developing a security model. And in that core, important thing is understanding the risk. What is your risk and control requirement is. You start with that premise, because important thing in a DFW or a security design is a policy. If you define it policy up front, you have a much easier chance to implement what that means and what's the enforcement logic is. Then the next comes is a scope or a zone area, right? Compliance zone, VDI zone, or an area called infrastructure zone, right? Then you define an access pattern. What are the access pattern? East, west, north, south, or a mix of that, right? And then from that access pattern, you find the dependencies, and then you group and create a policy model. So how do you do this, right? It's an important question is what methodology to use grouping, what policies, how many policies I should have, how do you automate all these things that we will cover these are the questions you need to ask. And you need to ask yourself a question is that, should I eat the whole thing at once? What is best way to optimize my security design? How do I work with the best bang of the work, right? So let's go through that questions, right? So once we identify the risk and the scope, that zone, and then you find saying, how do I find a dependency? Simple. You call a decide, default allow, or default deny. So now you are saying, I'm starting wide open, everything is open, like in brownfield design, or in a highly securitized design, everything is closed until I tell you what to allow. But in both cases, you log the traffic, or you can use a tool called VRNI, vRealize Network Interface platform, as well as we have a new feature called ARM, Application Resource Monitoring, and you can define and log it so you know what are the access pattern is. Also define the shared services rule, because that has to go on the top, because that's where your DNS is, that's where your NTP is, that's your Active Directory is, right? Monitor the log, new app and zone inventory, and then finally east-west rule, right? So I put that east-west rule as a separate bucket because that is the best way to start. By a single use of call a tag in NSX tag, you can isolate two VDI zone in one single rule. It doesn't need to be complicated, right? You now secured east-west, right? That's where the biggest proliferation of threat exists, because that's the largest attack vector that is open in the almost all network. North-south perimeter firewall, you have a reasonable access. You have a real perimeter in the internet, and then you have a data center perimeter if you are really aware of the security zoning, etc., right? So east-west traffic to me is a first way to get a handle on your design principle, right? So how do you do that policy model? So if you look at, there is an example I give here, just to get a idea that you have a zone 1 which is protected. There's a two different zone of your compute domain or workload. One could be VDI, one could be a production traffic. They have a access shared services. Of course, they have a common policy. So now you have a one policy that you can apply to both zone and zone 2. That means that policy needs to be separate from the policy for your zone 1 talking to your northbound firewall. I'm just giving you an example of firewall with a dedicated firewall or an interface. So what do you do with this is that you have a one policy for you to apply. So one place to change, another policy for north-south for this zone 1, which is in blue, another policy for another zone, and then you have an automatic policy saying, hey, in this case, I don't want to talk to each other, because zone 1 and zone 2 should never talk to each other. That is at the highest level, right? Now, you can go further in the zone 1 itself and define another set of policy that say app 1, app 2, or web cannot talk to app, etc. This is what we mean by a microsegmentation, because many times microsegmentation is an overused term. Everybody claims they can do microsegmentation. And also the degree of microsegmentation matters, right? You don't have to end up going directly here, isolating these applications from day one. And you don't have to create that policy merge with this guy or that policy merge with the northbound policy, because then you want a flexibility. Why do you need a flexibility? Because that policy model or a grouping will determine the complexity of managing those rules. As well as there is a feature, and now I'm talking specific feature called apply to field. Apply to field optimizes the firewall rule processing and span that rules per host. That means you don't have 100,000 rule, all gets applied to the same host everywhere. It's not a flat architecture. It's a distributed enforcement architecture. What is that value is that this is not your tradition. This is the fundamental difference in the traditional firewall, where you are creating a access list based on IP address, which is I call an assembly language, right? Nobody knows whether it grows or shrinks, because you cannot take the inventory unless you have a logging feature on, and you always do the active inventory. Here you are going above that object-based grouping, which is based on VM names, IP addresses, etc. Those are the attributes that goes into that policy, and that policy has a grouping that allows you to flexibly manage this access control, right? So it is a somewhat an art, and you can argue this piece that start with this type of a 3 or 4 fundamental policy model as a baseline and grow further into it, right? So I talked about these. That's why I mentioned about the east-west traffic rule, that it's easiest to do first a east-west traffic than determining all the access pattern that you have, right? Now, if you look at this, it's a kind of a one summary slide. That why do I talk this a summary way? It's a different ways of configuring securities, right? In the first design, I'm just doing a microsegmentation. Remember the first SMB design, small, medium, large design. In the first, there was a single cluster, only NSX manager, and I'm protecting east-west traffic. This design is very valid even for your DMZ architecture. Because in DMZ, your east-west is exposed. You can just deploy NSX manager and isolate that DMZ process, and you can optimize your DMZ design, because now you can host 2 disparate workloads in the same logical switch or a VLAN, right? Then you can grow into the full-fledged design as you progress. The final one is the final one, which includes east-west isolation, DFW VNIC. You have a edge firewall that's come through the distributed logical router, and you have a Palo Alto or other partner services that you trying to leverage for a deeper inspection or the guest introspection and other policy model, right? So there are set of tools available, right? And that is not complete. You can use those things. The important piece is that how do you do this called dynamic grouping, dynamic criteria, and how do you go about running a automated security model? So that's where the service composer comes in a picture. The service composer is allowed to create the workflow and allows you to use a VRA-based automation. So I have a few slides that are hidden, but they talks about how do I create a deployment. I know you don't like me keep using the hidden slide, right?
Yes, because I think about time. So
I know you have to plane to catch. I have plane to catch too. I hear you, my friend. There is a request to speak faster, so stop talking, right? So the idea is that you can have a security group that participate in 2 different policy. So you can change this policy and change the policy B and still impact the enforceability of the virtual machine. So naturally, this idea is that what do you do with the called policy weight, policy inheritance, and nesting of groups? Because these are the 3 things If you use too many weights, like a flat policy, that means you have to use weight. Now you don't know which order is important because the complexity. Now if you collapse the weight and use nesting, that means now you have to worry about which traffic has to go higher or what security group has to go in the front. So there is a balance of art, right, in terms of what you should design with. So do not go more than a 2 or 3 or maximum 5 nesting, right, level, right? We can allow a lot of different deeper level, but the rule processing gets complex. NSX manager has to process those rules on a multiple level because that security group can have a multiple VMs or 10 more minutes, right? I hear you. So I should stop talking. This is another outline that I try to emphasize that a lot of people don't know how to slice this. So it's a different phase approach that you can do in terms of security. The piece on a security, the other slide is important. This is a killer slide. Why? Because a lot of times I run into with the customer saying, hey, you're telling me to do east-west isolation. What about my physical network? Of course, physical network security is important. But why are we debating the east-west traffic more? Why? Because it's that life cycle of that application, agility, deployability, automation is more important because you just don't know which VM shows up next door to you. Or you want to consolidate different type of infrastructure in the single logical domain. In a physical design, how many times you change operating system? Not often. You don't just redeploy your databases overnight, right? So you have a problem of physical security. I'm not denying it. Work on your 80% of the problem or 90% of the problem, right? If you have a 80% virtualized asset, work on that first. If you have 80% physical asset, please talk to us so we can sell you vSphere license. Mobilize your workload. So you have a V2V problem with the distributed firewall we saw. But what about V2P and P2V? Because I'm solving 2/3 of all your problem because P2V or V2P is the same problem here as long as I stop the attack at the VNIC level. Or you can use the edge firewall combinations or a perimeter. Essentially, you are solving a 3 domains problem. P2P, you have access to ACL, vendor-specific rules, or ACLs to manage. They are relatively static. Unless you are offering a cloud platform of all physical workload, right? Which is possible. Some people are offering it, but most of the customers are worried about these two, and you solve it with a single stroke, okay? The piece that I care here is this is a summary slide to give you an idea of different use cases within the security and its level of isolation or what method you should deploy as a recommendation so you can have somewhat an idea how to design the security and what tools to use and what you can grow into, right? We support lots of certifications. 6.3 release becomes a FIPS compliant. There are HIPAA compliance that we adhere to it or we comply with it at higher level standard. We also have what you call common criteria, which is normally used by the defense, and it becomes a standardized reflections on a European or other continent as well, right? The last 2 slides that I will talk is the summarization of NSX SDDC use case. So you talk about this use case in the first slide. Not all use cases require all component, right? We talked about it. We have a flexibility in the design. What is important, here is a classical example. Dell EMC offer called a full-blown solution. In this, they are having a classical design with the distributed logical router running a tenant production traffic over here with 4 ECMP, but they also have an automation pod. So automation pod where all that automation workload reside, that runs a separate DLR, but it doesn't need a lot of bandwidth, so they run with the dual ECMP design. If you notice it, that they are having a multiple VDSs. They dedicate VDS for management and storage separately. They use dedicated VDS for their tenant, and there is a separate VDS for your automation for resiliency. So this conversation about how many VDS or what should you use, it will depend upon how elaborate and what are the requirements that you can work with. So if you have a classical requirement like that, which requires a lot of complicated design, of course, we will work with you with the SA services or PSO in order to normalize your design, right? So talk to us, right, if you have a complicated requirement, right? And usually your contacts works within our internal BU to validate the design or scale that you need, right? The other design that I talk, this is new. We will have a design guide on a Pivotal Cloud Foundry with NSX. How many people know what Pivotal Cloud Foundry is? So PCF is another higher level services that runs a application platform or a platform as a services that have a elastic runtime services. There are different nomenclature. The requirement here is that there are different type of services that runs, and all of these services may require a load balancer or a NAT, because you are deploying these application instances in a repeated fashion. That means duplicate IP addresses. So you will need NAT, right? Depends upon your configuration design. Here the key part is that you have a network compute and a storage infrastructure that is all software defined. And how do you design with the PCF is a question. So we will reuse some of the component argument. In this case, my friend, the 3-tier architecture or 3-rack design will make sense. By default, PCF recommends you to run a 3 different cluster because it's an availability zone concept of 3, because their BOSH and Go router services works on that called quorum of 3, just like the controller of NSX runs on a quorum of 3. So they put a services on a 3 different cluster. That also means I normally map that cluster requirement into a 3 different logical switches, 3 different subnet. But here I'm doing a very simple design. I'm running a centralized edge, 4 network that they recommend to run, production, elastic, runtime, etc. And you're running a load balancer, NAT, or other services here in order to serve it. This is a classical, call a baseline PCF design. You will find in a PCF handbook as well. But that's a classical design, right? They start with that. Now, how do you grow into it? So this is where I talk about this standard design, 2 ECMP, control plane, control VM in a 2 different minimum 3 host as a starter design, as we were talking in a beginning of the session. Then you grow into a 3-rack design, 3 cluster design, and a 3 availability zone. So if you notice it, that gentleman asked the question, can I use a edge services as an independent edge services per cluster? So here, look at the design that we are proposing. We are doing a 2 ECMP, 1 ECMP per zone. There is a total 3 PCF foundation, each running its own edge services, each running its load balancer and the NAT translations, and each is housed in a 3 host with the availability considerations. So this is a classical mapping of 3 racks, 3 clusters, and I'm running now the importance of VXLAN will come in the picture. I'm running a logical switch across this 3 cluster. So any of that services fail, by the way, that PCF services runs on a layer 2. Because it wants to give automatically a same IP address. That IP address management get easier if you run on the same subnet, right? So if the failure of one host occurs, that services occurs here, the BOSH who runs the availability as well as the orchestration engine automatically knows how to restart services on a different host or different availability zone. Why do you need that VXLAN wire to be available there? That is the reasons you run a VXLAN across these 3 hosts, a logical switch, because that switch is already available and you run that services automatically without changing IP address. So that's the availability requirement that you can see. So I'm utilizing the VXLAN availability model, the availability model of a 3-rack design, as well as a ECMP design on a single rack. You can stretch this rack on a more than one rack, but only requirement there is that I have to stretch the VLAN or a BGP relationship between these two TOR and these two TOR. It's doable, and it will give you a higher resiliency, right? So the idea here is that a summarize that I will tell you is that there are a variety of options available. Use those options as per guideline. You can always break some rules, right? If you're imaginative, if you have a requirement, talk to us, right? So that we can assure you that a compliance is met or supportability, or whether we are doing a deeper QA on certain topology, etc. But this design guide will be available within a week on our document pages, right? I have nothing, I have probably a small, our ecosystem has grown. This is a marketing slide. The reference design guide, this is all available on a community.vmware.com, and if you undergo NSX and under document, the design guide that we discussed here in 2 parts is also available, as well as other design guide, right? So for the brownfield design guide for an NXOS, the Cisco design guide, there is an operational design guide, there is a whole full slew of document available to you, right? So I hope you had a good time at the VMworld. And we should probably finish this by saying, fill out the survey, make a comment. You can also make a bad comment, good comment, ugly comment. By the way, yeah, it's important. 1 is bad, 5 is good. Just 1 is normally not a good thing, right? I'm not asking you to say, do that, but thank you very much. I appreciate it.